Okay, let's unpack this computer science degree thing for 2025. You're probably wondering, right?
Mm-hmm.
Is it really worth the time, the money, especially now?
Yeah, with tech moving so incredibly fast, does that diploma still mean what it used to?
Exactly. Is it your launch pad?
Yeah.
Or are, practical skills and just learning online the better way now? That's what we're really digging into today.
And what's striking is just how many different takes there are on this. We've gone through articles, lots of comments online
Oh, yeah.
from people in the industry, some with degrees, some without, academics too, and even current students. It's quite a mix.
It really is. So
Yeah.
our mission here is pretty clear.
Yeah.
Cut through all that chatter and give you, our listener, a really balanced view.
Help you understand what a CS degree offers now and maybe where it's headed.
Right. We want those aha moments for you.
You are listening to Merge Conflicts Real Dev Talk, where passionate developers tackle code, culture, and everything in between.
Without getting totally bogged down in jargon.
And it seems like a lot of this debate, maybe the core of it, is just the sheer speed of change, AI especially.
Oh, definitely. That keeps coming up. This worry about whether a traditional, 4-year program can even keep up.
Yeah.
Someone commented, basically, will the tools I learn even be relevant when I graduate? Which, is fair.
It's a genuine concern, and it ties into that older idea of university, doesn't it? Originally, it wasn't just about job training.
Good point. More about knowledge, critical thinking.
Exactly. But let's be honest, most people going into CS now are thinking very much about that tech career.
Which leads straight to the argument that, well, maybe you don't need the formal degree anymore.
Because there's so much out there online. Practical experience, boot camps.
Right. You can learn coding online, build a portfolio. So why the 4 years? Some argue it's becoming less essential for just proving you can program.
And that viewpoint often points to employers, saying they prioritize what you can do, your projects, your demonstrated skills.
Over the certificate itself sometimes.
Maybe. And then there's the money factor. We have to acknowledge that.
Oh, yeah. The high salaries in tech are a huge draw.
So are people choosing CS for the love of the subject, the intellectual challenge? Or is it mainly about, the paycheck down the line? That question came up.
It's a bit cynical, maybe, but probably true for some.
But here's a twist on that, linking back to AI.
Okay.
The argument some sources make is that if AI starts handling the more routine coding, then having that broader, deeper foundation from a degree might actually become more important, not less, for long-term survival,
Interesting. So the basics become more valuable if the basic task gets automated.
Potentially. You'd need that deeper understanding to manage the AI or solve problems the AI can't.
Okay. But let's flip this coin. Because there's a really strong case for the CS degree too, right? It's not all doom and gloom.
Absolutely not. And the core argument there is about the fundamentals.
The stuff that doesn't change every 6 months.
Exactly. Things like, Boolean algebra, logic, algorithms, data structures. That's the bedrock. It underlies all computing, including AI.
Right.
Someone made a great point. If you don't understand that history, that foundation, you're kind of navigating the future in a fog. Those principles stick.
And it's more than just the technical stuff, isn't it? The degree process itself.
Definitely. It builds other crucial skills. Critical thinking, solving problems from scratch, abstract reasoning.
Learning how to learn new things, which is huge in tech.
Yes. And approaching problems systematically, like a scientist. You don't always get that depth from just, say, a quick online course.
It's like it gives you a whole framework, a way to talk about complex problems.
That's a good way to put it, a shared language or vocabulary. It pushes you towards deeper understanding, not just surface knowledge, knowing how versus understanding why.
There's a big difference there. I saw one analogy comparing it to, training a language model.
Oh, interesting. How so?
You're not just feeding it data. You're building its ability to analyze, infer, connect things.
Yeah.
The degree process does that for your brain, supposedly, cultivates a certain way of thinking computationally.
I like that. And it speaks to the intellectual rigor, especially the math side. Several people mention this.
That it actually changes how you think.
Yeah, that grappling with tough, abstract problems literally shapes your brain, builds logical pathways. That's a long-term benefit, way beyond your first job.
Let's be real, the practical side. Employers still see that degree.
Oh, for sure. It's a signal, a validation.
Like a stamp of approval. Shows you can stick with something difficult, manage a long project.
Exactly. It functions as a filter for hiring managers, whether we like it or not. Saves them time, maybe?
And the people you meet. The network.
Hugely important. Your classmates become colleagues, maybe co-founders. Professors can be mentors, write recommendations. You build connections.
That's not something to easily replicate learning solo online.
Not really. And then there's the argument about tackling truly new problems.
The stuff AI can't do yet.
Right. That requires creative thinking, adaptability, often drawing on those deep fundamentals the degree provides. You're equipped to innovate, not just apply existing solutions.
And finally, just pragmatically, if the job market gets tighter,
Yeah, especially if AI does impact entry-level roles.
that degree could be the edge you need, couldn't it, to stand out from the crowd?
It certainly could provide an advantage in a more competitive landscape.
So this brings us back to the universities themselves. There's this tension, right, between how fast tech moves and how, well, academic institutions tend to move.
That's definitely a core tension highlighted in the sources. Curriculums often lag behind the absolute cutting edge. They might not be teaching the hottest new framework the day it drops.
But the counter-argument we heard a lot was that's not really their main job.
Exactly. They're not supposed to be purely vocational schools chasing the latest trend. The goal is that broader foundational education we talked about.
The principles that last longer than any specific tool.
Precisely. And some suggest that maybe the responsibility for teaching the very latest job-specific skills is shifting more towards employers.
Companies doing more in-house training, continuous development.
It makes sense. They have the incentive to keep their workforce current.
We also saw some people wondering if the degree structure itself might change.
Yeah, like could we see shorter programs or maybe more integration with work like co-op programs or longer internships built in?
That's possible down the line.
And we should also remember, as a few sources noted, that research is a huge part of university life, pushing boundaries, discovering new things. It's not just about teaching undergrads for jobs.
True, but focusing back on the learning aspect for undergrads,
Yeah.
even if they aren't teaching the very latest thing.
The degree gives you that big picture context, right? Understanding how things actually work under the hood.
Yeah, like what is binary or hexadecimal? How does code get compiled into something the machine runs? What a database is really doing? Algorithms.
Compilation is a great example, that translation from human-readable code to machine instructions. Understanding that process is fundamental.
It helps you know what you need to learn next, how it all fits together. Maybe harder to grasp if you're just picking up bits and pieces online.
Definitely. Which leads us into some of the nuances here. Because it's clearly not just a simple yes or no answer to whether a CS degree is relevant.
Not at all. It seems to depend quite a bit on what you want to do with it.
Exactly. If you're aiming for, say, theoretical computer science research, that deep academic background is probably crucial.
More so than if you just want to build websites or mobile apps, perhaps.
Perhaps. Though fundamentals help there too. But we also have to acknowledge the success stories of people without degrees.
Oh, yeah. Plenty of brilliant, self-taught developers and tech leaders out there. Talent and drive go a long way.
Absolutely. And it's interesting to compare CS to other engineering fields.
Like aerospace or civil engineering.
Right. In those fields, the degree is still seen as pretty much non-negotiable. For safety, for demonstrating core competency.
Makes you wonder if parts of software development, especially critical systems, might head more in that direction eventually. More formal requirements.
It's a possibility being discussed. And another thought-provoking idea is how AI tools might interact with this.
You mean instead of making degrees less relevant, AI could? What?
Could actually widen the gap. If you don't have that strong foundational understanding from a degree, you might struggle to use advanced AI tools effectively or critically judge their output.
Okay. So the tools become more powerful, but you need more understanding to wield them properly.
Potentially. We also heard the argument that the value proposition of the degree might be shifting.
How so?
Less about proving, specific skills today and more about demonstrating those transferable qualities.
Like perseverance, adaptability, the ability to learn hard things.
Exactly. Qualities that employers value in any field, especially one that changes so fast. The degree becomes proof you can handle complexity and learn.
And then looping back to motivation for a second.
The money versus passion thing.
Yeah. The point was raised that if your primary drive is just the salary, maybe you don't engage as deeply, and you don't get as much long-term value from the degree process itself.
That makes intuitive sense. But on the flip side, many sources stress the value beyond the job market.
Personal growth. Thinking skills.
Right, becoming a more informed person, developing critical thinking that applies everywhere in life, understanding the technology shaping our world. that has value in itself.
Especially for you, the learner, thinking about your own development. It's not just about the first job.
Precisely. So, wrapping up this deep dive, it's clear the relevance of a computer science degree in 2025 is, well, complicated. Lots of valid points on every side.
Yeah, you've got the super fast pace of tech, AI changing things, all the online learning. Those definitely raise real questions about needing a traditional degree for certain jobs right now.
But that degree still offers a pretty solid, lasting foundation in the core principles. That hasn't really changed.
And it develops those cognitive skills, thinking critically, solving problems, learning how to learn, which seem likely to stay valuable no matter what tech comes next.
Plus, the practical advantages in the job market, the signal it sends to employers, the network you build, those are still very real factors.
Definitely. So for you, the learner, the key takeaway is really understanding all these different angles. There isn't one single answer that fits everyone.
You have to weigh these factors based on your own goals and circumstances.
Okay, so here's a final thought to chew on. As AI keeps getting more powerful, could it be that the deep foundational knowledge and the critical thinking you get from a CS degree actually become even more crucial? Even if the specific tools you learned in class are outdated, maybe that underlying way of thinking becomes your biggest asset. Something to consider as you figure out how best to equip yourself for the future.
A future where, most likely, both cutting-edge skills and that deep conceptual understanding will be highly prized.
Indeed. And rest assured, the deep dive will keep exploring how education and technology continue to shape each other, helping you navigate it all.